Alright, so we'll begin, guys. Today we're looking at 11E. So we'll pull our notebooks out, please, guys. Get started. 11E. So we've got the normal distribution. So maybe some of you have seen this before, maybe you haven't, that's okay. We'll go through it nice and slowly. And this is really sort of the crux of statistics, that everything we do in statistics is based off of this, I think. And so this is what you move into the further into senior school you get. And so what we have is many things that you measure, in fact almost all things you measure will be normally distributed. So a classic example is height, okay? We can calculate the average height and that's going to be the mean. Now the very fact that it says average means it's in the middle, right? Which means 50% of people are going to be taller than average and 50% of people are going to be shorter than average, all right? So you have the mean in the middle. And then this symbol here, this is called sigma, okay, it's another Greek letter, and this means standard deviation, and I've said it's a measure of spread. And now notice that the closer you are to the mean, the more probable it is, all right? And as you move further away from the mean, it gets less and less likely. That is, it's less and less likely to have someone that's very small, and less likely to have someone that's very, very tall. Most people are close to average height. Okay, it's the same with everything that we measure. All right, even if we were to do distance you live away from the school, something we would anticipate is normally distributed. Okay, so let's get straight into the example here. So this is the bell-shaped curve, and let's do the example. We've got the height of year 11s is normally distributed with a mean of 175 centimetres and a standard deviation of 8 centimetres. So part A says to draw the distribution. So if we're going to draw it, okay, we're going to draw a bell-shaped curve, and the line in the middle is the mean, okay, and the mean is 175 centimetres. All right, so that's the first one we're doing. And so what this means is 50% of year 11s are taller than 175, and 50% are smaller than 175. Okay, we have a standard deviation of 8 centimetres. So that means my next line here, all right, is going to be 8 centimetres further along. That's going to be 183. And then another 8 centimetres along, 191. And then another 8 centimetres along, 199. Okay, so there, that's the mean plus 1 standard deviation. This is the mean plus 2 standard deviations, and the mean plus 3. And we go back the other way as well. 8 centimetres below 175, 8 centimetres below 167, and then 8 centimetres below 159. And we'll fill in the probabilities here. So just roughly 34%, 13.6%, and 2.13%. All right. Fill it in here. 34, 13, and 2.13. Now those probabilities are always the case. If you've calculated the mean and standard deviation correctly, all right, what this means is 34% of year 11s, based off our distribution, have a height between 175 and 183. All right. In fact, you can double it and you can say 68% of year 11s lie in this interval between 167 and 183. You can see the vast majority, whereas you only have 2% that are taller than 191 centimetres, and you have 2% that are smaller than 159. So you can see most of the results congregating around the middle. It's bell-shaped, that's what we expect. Most results are close to average. Okay. Let's address some of these questions then. Part B. Determine the probability of a year 11 having a height that is, and the first one says between 167 and 183 centimetres. Okay? So 167 to 183, that's this region here, right? It's from here to here. So to calculate that probability, we're adding these percentages together. So it's going to be 64.26%. Okay, so that's a percentage, all right? Now, as a technicality, whenever it says find the probability, a probability is always a number between 0 and 1, right? So if we want to convert that to a decimal, we divide it by 100 and we'll get 0.6426. You can just put that in your calculator, divide by 100, just moving the decimal place 2 spaces. Okay, so the probability of a year 11 being between 167 and 183, 0.6426. On to the next one. All right, we have what about a probability that is less than 167 centimeters? Okay, that's it being from here, 167, downwards. All right, so now we're interested in this area, right? From 167 to the left. So we've got 13.6 plus 2.13. That's going to be 15.73%. Now I haven't put these numbers in here. So in here it is like 0.27%. It's very little. So let's put that in, and then when we add it up, we've got 16%. All right. Okay, that's part 2. And then part 3, more than 183. All right, so we've got that one there. Okay, more than 183 is going to be this one here. And we'll see again, so part 3, 13.6 plus the 2.13 plus the 0.27 will be 16%, or 0.16 as a probability. Right, both as a probability. Okay, so all you're doing is adding up the percentages and then converting it to a decimal on the diagram. Now, if we were to add all of these up together, okay, what we can see is that it's going to allow every possible event, okay, less than 167, between 167 and 183, and more than 183. If we add all of those up together, the probability will be 1, because when you add all events up together, the sum of all probable events is 1. Okay, that's just something to point out. So that's how we can use the normal distribution curve to perform calculations. However, most of what we will do will be on our calculator, and so that's what we're going to do next. Perform the following calculations using technology, state their significance. Okay? So part 1 says, find the probability of the height being between 160 and 170. Okay? That's what this statement means. The probability that our variable, what's the variable we're talking about here? Height of year 11s is between 160 and 170. Now we can't calculate this based off of just the curve and adding numbers. And the reason is 160 doesn't show up as one of the numbers here. And neither does 170. So 170 is like here, and 160 is like here. So we're calculating this probability, and we can't see the numbers that it corresponds with. So that means we need to use our calculator. All right? So I'll take you through the calculator instructions. We go into menu, we go statistics, distribution, normal, and NCD. Okay? So that's the calculator instructions. All right. Statistics, distribution, normal, NCD. Okay. Now, there's a number of settings. Okay, firstly there's data. All right, you need to make sure that is set to variable. Data is set to variable. And then you'll notice there's lower, upper, standard deviation, mean. So I'm going to write it out like this: lower, upper, standard deviation, mean. Well, the mean of the distribution is 175 centimeters. The standard deviation is 8, so we can fill those in. The lower boundary is our lower end here. Okay, our lower boundary is 160, and our upper boundary is 170. Okay, so that's the calculation that we're going to perform. So I'm going to go 160, 170, 8, and 175, and then we just press execute, evaluate, and our answer is 0.2355. Okay, that's to 4 figures, and then round to the third, 0.236. All right, now I'm just going to check, does anyone need any help with that calculator skill before we address the next two together? Any questions about it? Okay, so...
What we're doing, putting one in, which percentage?
Yeah, execute, yeah. Yep, sure. Okay, so let's move on to C part 2 then. Okay, C part 2. Find the probability of x being less than 180. Now maybe just before we move on to that one, I want to point out the difference between these two. Okay, this statement here means less than or equal to, and this statement means less than. Now, for normal distribution, for continuous random variables, what we're talking about at the moment, there's no significant difference between them because these exist on an interval. They're not whole integer values, so they mean the same thing. Don't be alarmed if you see one pop up and it's not the other. It doesn't matter what you write, they mean the same thing at the moment. Okay, so we're saying now, probability of x being less than 180. So 180 is going to be like here, and so we're saying, well, probability of x being less than 180 is going to be all of that area there shaded, right? All of that. And so I know it's going to be more than 50% because 50% is there, and so it's 50% plus this little bit. But I don't know how much it is, I have to use my calculator. So same thing, we're in distribution normal NCD. We've got our lower boundary, our upper boundary, our standard deviation, and our mean. Now, the upper boundary, if you look at the diagram here, the upper boundary is 180, right? That's the top end. So we've got the upper boundary. I'll fill these in. We've got the standard deviation, we've got the mean, and then we need to put in the lower boundary. Now, the lower boundary, because it's a normal distribution curve, it's what we call a probability density function. You go on to study Year 12 methods. These tend to infinity in both directions, which means our lower boundary is not 0, it's not minus 1,000, it's going to be negative infinity. All right, and of course it doesn't make sense to have a height of negative infinity, but in order to perform the proper probability calculation, that's what we need to put in. So the way you type in negative infinity in your calculator is you first, so we got the lower boundary, all right, and you're typing in the negative, which is where the answer button is, right next to execute, negative, all right, and then you'll notice there's either, depending on the model of calculator you have, right next to the negative button on the left, there's times 10 or EXP or something like that, so press that one, negative, times 10, and then just type in the numbers 99, okay, 99, and press enter. So that's negative 1 times 10 to the power of 99. So what that means is it's minus 10, it's minus 10 times 10 times 10 times 10, 99 times. Like, this is an enormous number, right? It's negative way large, okay? So we've typed that in, negative 10 or negative EXP to the power of 99, and the upper boundary 180, standard deviation 8, mean 175. We'll evaluate that. And the answer we get for this one is 0.7340, and it's a 0.734. All right, part 3. C part 3. How about the probability of it being larger than 185? All right, so notice sometimes they're using greater, sometimes they're using greater than or equal to. So if we draw our distribution, the mean is 175. So 185 is going to be like here, and the probability of it being larger than 185, we're talking about this section, right? So our lower boundary is going to be 185, and I've said it's tending towards infinity there. So normal distribution calculation, lower boundary, upper boundary. The lower boundary is 185. Standard deviation is 8. Put those around the correct way. Okay, now for the upper boundary, we're not going to write negative infinity, because if you keep going this way, you don't end up at negative infinity. Instead, we're going to put positive infinity, yep. So the same as what we did, except without the negative out the front. So times 10 to the power of 99 as the upper boundary. So we're going from 185 to infinity, and we've got 0.1056, 0.106 to three significant figures. Okay, so if it helps to establish what the lower and the upper boundary is, draw these diagrams, all right? If it's asking for larger than 185, you know, that means 185 and upwards. If it's saying less than 160, it means 160 and less than. All right, if it says between 160 and 185, well, it's talking about that region, isn't it? Okay, last one where it's going to get a little bit different. What is the minimum height someone needs to be classified in the tallest 5% of people? So what's going on here? This is a little bit of a different calculation. What we're saying is, here's the normal curve, and it's got a mean of 175, and we're saying, how tall does someone need to be in the tallest 5%? So that's the tallest 2%, right? So the tallest 5% is going to be like this region here somewhere, okay? This is 5% of the area under the curve. 5% as a probability, 0.05. And so we're saying, what's this value k? What's this value k such that that's the minimum height they need to be in the tallest 5%? Okay, they're considered the tallest 5%. So we're saying, what's that number k? All right, so similar process to what we do on the calculator. So we're in statistics, we're in distribution, we're in normal. We don't press NCD, we press inverse normal because it's an inverse calculation. Rather than calculating the probability, we're given the probability and we're trying to establish what value is it true for. So if you follow the calculating instructions to here, all right, if you're a bit lost with the calculating instructions, just press exit lots of times and then just start again. Distribution, normal, inverse, normal. All right, so let's take us to that point on the calculator. And we're told the top 5%, we're saying, what number's that? So we go, yep, distribution, normal, inverse, normal. Okay, again, we're confronted with a number of settings. Make sure, firstly, that data says variable. That's always our setting. Okay, then we have the tail, then we have the area, then we have the standard deviation and the mean. Okay, these are remaining the same. The standard deviation and the mean, they're not changing, so we can fill those in. Now the tail is which end of the region is shaded. Is it the right end, is it the left end, or is it the middle? And we can see the right end is shaded. Our tail is right. So when you scroll down to tail, you'll see you've got three options, left, right, or central. Our tail is right because we've shaded the region to the right. Another way this statement can be written is, what's the probability of the height being larger than k such that it equals 0.05? All right, that's what this statement means, right? The probability of height being larger than k is 5%, right? And notice how the arrow is pointing to the right. So that's another way of thinking about it. And the area is the probability, 0.05, 5%. Must be expressed as a decimal. So if we put all of that in, right, 0.05, 8 and 175, we've got 188.15. All right, 188 centimeters, okay? If you're taller than 188 centimeters, you're in the top 5% of height. Okay, any questions about this then? All right, so let's just go to our checklist quickly because we've got 11E. Alright, so we've got questions 1, 2, 3, 4, 5 and 6 from the book. Now most of those questions you don't need to use your calculator, but you can, alright? I encourage you to be familiar with your calculator. So we'll start with those, and then you'll notice I've got normal distribution questions on page 29 of your notes book. These are ones using technology. So from memory, the textbook doesn't ask any using your calculator, but we're going to do these ones as well. So start with the textbook, then progress to here, page 129, and we have done enough now to do the quantiles questions as well. That's this kind of stuff here. So that's our plan for today, 11E. Let's shred it.